Okay, so again, you'll see the screen as is, okay, and hopefully you'll hear my voice at the same time. The question we're looking at is the one from the notes here. 9 kilowatt load, 230 volts, yada, yada, yada. You'll have a read of that, no problem. And just for if you weren't in the class when we were doing this, the actual value of the conductor should be 16 squares. So if you are watching the video, you can see it on the board anyway. Wonderful. Let's reproduce this in Ecodial to see if we get the same results. So I have Ecodial open here at the moment. If it's your first time using it, it will ask you to register. Obviously, if you'll have to make your own account, so do that as I instructed in the email. But how do we use this software? We use it to draw single line diagrams. We can feed it some information and it'll output all the missing items that we need. So I'm creating a new project here to do this. Lovely. And if you're new to this software, it's grand, it's going to take time to get used to it, but the interface is pretty nice, okay? Even though it's limited, I think, in certain aspects. But this screen here is where you're going to draw your single line diagram. As you add items to that, you can edit the properties. The properties is on the right-hand side. You'll see it's listed there, properties. And all the items you can add are here on the left. To do this, we have to add a source of energy, some sort of distribution, and a load to make up our cable. Going between those different elements in the circuit are cables. So we'll have a cable coming from our source to our distribution, then from our distribution down to our load. And then just to clarify, that's the source. That is the load, and that's our distribution or our bus bar. To go back to what we looked at on, I think it was probably the first set of distribution notes, these will be labelled using that notation for three-phase, neutral and earth. And our load is what, single or three-phase? Yeah, single phase. And there'll also be some protection devices listed on that single line diagram. So again, just like what we did at the start of distribution, it's a way of looking at an electrical installation. It's telling me we have a source, three-phase cable, bus bar, single phase cable, down to our load. And just to remind ourselves, the details of this question are, it's a 9 kilowatt load with a power factor of 0.85, isn't it? Yeah. And in terms of the cable that we're trying to design, it's B1. So we'll look at the regs and what that means now in a second. The ambient temperature is 35 degrees, isn't it? Yeah. In terms of grouping, how many more circuits are there? 2 additional circuits. Plus 2 circuits. And it's 20 meters in length. So the object here is to take all that information, put it into Ecodial, hit go, Ecodial will spit out the correct size cable. Just like we did here by hand. Is that all right? Lovely. Let's try and do that with Ecodial. So, again, you're going to draw your single line diagram. You have sources. You have a look, you'll see there's an LV source, there's MV generators, there's substations, whatever you need. We're just going to stick with an LV source. We need a bus bar, so that's under distribution. We'll add that in. And we need a load. I'm picking a generic load here as opposed to lighting or motors or sockets. If you pick a specific type of load, it's going to suggest particular types of protection on the circuit. So if you pick a socket load, it automatically puts in RCDs. If you pick motors, it puts in type C MCBs and whatnot. So again, we're just doing a generic load That's my single line diagram done. And now we're going to work down through the system to make sure we have everything put together as needed. First thing I'm going to do is I select my source. Again, like I said, you draw your diagram, you edit the properties on the right-hand pane. The first thing we're going to edit is I'm going to make this a public distribution system. And keep an eye on what happens, how it changes on the single line diagram. So, I'm just doing it as an example. If you look in the regs, for example, you'll see that volt drops change depending on whether it's private or public supply. So it comes down to that. Now, you'll also notice there the little earth got added in on our bus bar in that part. When you select an item to edit it, it gives you generic kind of up level properties to change, but you can go to specific parts to change them as well. So I'm going to go in further into the source, and I'm going to tell it that it's a TNS earthing system. Okay, as far as I'm concerned, that's enough to do with the source. Just to clarify, we made this public and TNS. That goes back to our earthing systems, remember? A few weeks ago? Perfect. Was that before Halloween? Yeah. A month ago. Okay. Right. That's the first thing done. You've defined your source. Next thing is we're going to define the load. If I pick the load, it gives me, again, high-level properties to edit first. Kind of like the main things without going into detail. So we can tell it the earthing system. It matches with the source automatically. We can design this by power or current. Which one do we have? Power. So let's give it the power. Now, we can enter the power, the real power, P. It's 9 kilowatts, isn't it? Yeah. Okay. And it automatically corrects or automatically calculates every other value as needed. 9 kilowatts, is our power factor okay? Yep. Is our design current okay? Okay. Where do you see that? Yeah. It defaults to a 3-phase load. So if you're looking here, you'll see it has 3-phase and neutral as default. If you didn't spot that, you could also look at the diagram. It's defaulting to a 3-phase neutral and earth cable. So already, if you're reading the diagram, you'll have the same information.
What does a one-phase look like?
A single phase, like you mean just a single phase load?
Yeah, like
So 1 phase, 1 neutral, 1 earth. And you'll see it here. When I select it now to go to single phase and neutral, changes it. Okay. We can also put the cable length in at this point as well. How long is my run? Okay. And you'll see the current's been calculated. 45.8, 46.3. There is a bit of a difference there for some reason. That's unusual.
it uses the 230 volts from 400 volts, so if you divide it by 3, you get the exact value.
Ah, really? Ah, very good. Did you go reading about that?
No, I haven't looked at it.
So you're saying then 400 by the square root. Yeah, let's have a look. So function of 11. 400 divided by the square root of 3. Okay. So you're saying 230.94. 9,000 divided by that times 0.85. Oh yeah, good. Well spotted. All right. So we're saying it's 230 volt single phase, which, you know, it kind of is. The issue is not an issue. The reality is in this system, the source is a 400 volt three phase, so that little 0.94 of a volt is making that much of a difference. Good spot. Make sure that's in your report. And don't rob it on it. Right? I know. That's very well spotted. Fair play. Okay, so we now know we have the right current. So if I'm doing this problem out, I absolutely am coming along and going, yeah, that's in, and that's in. So what's left to put in? That's one of them. Temperature and grouping, yeah, they have to go in as well. So we can go into some more specific properties about the cable here. The information that comes up on the right here, you'll see it looks for things like materials, length, insulation, type of cable, and installation method. So we go back to the question. Does it say anything about the material of the cable? Is it aluminium or copper? Copper, yeah. Copper's in the first sentence there. Copper cable. So we make sure it's copper. It already is. That's default. Does it say anything about the insulation type? PVC, yeah. So we'll set that to PVC. Wonderful. Is it multi-core or single core? I heard multi and single, so who thinks single? Who thinks multi? Who doesn't want to answer? How do we know? How do we know? Single core copper cable. If it didn't say single core, how would we know? It could not say single core. It's in conduit. That's that you could argue. Yeah, you wouldn't be putting. Well, you can put multi-core cable in conduit, can't you? Right, that's not a problem. How can we really go and actually explicitly state that it definitely is multi or single core though? Go back to your tables. And yes, installation methods. And what did we say it was? B1?
Yes, B1, yeah.
B1. Insulated conductors, single core cables. And it also says they're in conduit on a wooden wall. Okay. So for definite, that should be single or multi-core. Single core, right? Okay. And again, like any problem, go back and make sure you tell yourself, yeah, there's nothing we can really tick off there just yet. So the last 3 bits are still to be put in. How we do that in Ecodial is this blue link here. We open this up and it gives like an interface to input the rest of the information. And we'll start from the top down. Do we know the ambient temperature on this circuit? 35 degrees. So you can define that by circuit, or you can tell it for the whole installation it is 35 degrees. That's something that's done in the properties, the project parameters up at the top left there. Okay. That's done. What's B1? It's conduit on a wooden wall. Apparent means we can see it. Conduits, wooden wall. Comes up as B1. So for example, if it was cable ladders, horizontal perforated trays, it's reference method F, but it's not. It's conduit, wooden wall, it's B1. That's done. Yeah? Lovely. Okay, how many additional circuits have I got? 2. 2 additional circuits. That's that done. At that point, we have everything in the problem put into the software. What happens now? We tell the software, do the heavy lifting. So I'm going to hit calculate project. It's going to go and work back up through the network and see, kind of do everything from cable size protection devices and up through. We're only interested in the results in this cable though, just to be clear. Well, let's do it. Calculate project. You want to save your changes? If I were you, I would. In case. I'm okay. Goes through any calculations it needs to go through. We're happy, got it. And the results are put up on screen for us. Okay. Now, 16 square copper. Is that what we said it should be? Okay. And that's the extent of what I expect you to do with the software. We've got 16 square copper, 20 meters, 9 kilowatts, 0.85. There's only one circuit, but the cable size takes into account that there are two other circuits. Does 50 amps match with our nominal device? Excellent. And that's it. So a screenshot of those results is really handy. That's probably the best way to put it into your report. The other thing that's nice about this is that's a solution, that conductor size. It also gives you calculation results. So, I'm out of room. Let's do it here. You remember what the equation is for calculating our volt drop? Plus lambda L sine phi IB. You'll go through that process as well, calculating the volt drop. Is there an easier one? That's it now. Hmm? I'm not aware of a smaller one, and I get you. It looks painful, but it comes if it's in the exam, you'll be given it. Yeah, in the old standards, it was a table of millivolts per amp per meter for different cables, and that was a case of multiplying it by the distance and the current. I'm not saying this is the better way or the right way. I'm saying this is the way, and that's all I have to say. Right? Like, I'm aware that the older way was definitely more convenient. I think they're trying to make this a much more generic way of looking at it because it incorporates impedance in terms of resistance and reactance. So, but just to finish off this video, because it's going to be, we'll keep it at that. The other thing you can do is if you hit calculation results, it spits out some other little bits, including your volt drop. Tells you for that circuit you're likely to have 1.1%. So is that within our allowable volt drop for a non-lighting load? What is it? 5% for non-lighting?
5%, yeah.
Yeah. So it's a 1.1%. And the thing is, once you have this done, the beauty of these pieces of software is someone might come along and tell you, actually the run is 40 meters, change all your calculations. Now it's just a case of changing the length of 40 meters and rerunning the project. You don't have to go through all the hand calculations again. Let the computer do the heavy lifting. So it says 16 square is still good. Perfect. But the volt drop is twice as much now because you have more length in the cable. Maybe what actually changes about the load is the size of it. Maybe it actually turns out to be a 12 kilowatt load. That increases the current. That's okay. We can rerun the simulation, get new values. And now they're saying, well, actually, based on that new current value, you need 25 square. And does the volt drop change? Yeah, it's a little less, but... So do you see how the software is nice for doing that? Once you have your network defined, you can change the values and get results very quickly out of it to calculate the rest. Is that okay? Any questions? Okay. I'm going to just stop that recording and I'll get it up onto YouTube as soon as possible. Stop